Giant meteorite impacts cause massive extinction in the late Cretaceous, study confirms. These data would confirm that the extinction was caused by something completely external to the Earth system. This is from the University de Barcelona. A study published in the journal Geology rules out that extreme volcanic episodes had any influence on the massive extinction of species in the late Cretaceous. The results confirm the hypotheses that it was a giant meteorite impact what caused the great biological crisis that ended up with the non-avian dinosaur lineages and other marine and terrestrial organisms 66 million years ago. The study was carried out by the researcher Cesc Battenberg from the Faculty of Earth Sciences of University of Barcelona and the experts Vincent Gilabert and Ignacio Arenelas and Jose Antonio Ars from the University Research Institute on Environmental Science of Aragon, University of Zaragoza. The KPG boundary, the great extinction of the Cretaceous in Zumaya coasts. The scenario of this study were the Zumaya cliffs, the Basque country of Spain, which have an exceptional section of strata, and we can see them right there. It's coming right there, look at that. It's going from vertical to horizontal. These section of strata that reveals this geological history on the Earth in the period 115 to 50 million years ago. In this environment, the team analyzed sediments and rocks that are rich in microfossils that were deposited between 66.4 and 65.4 million years ago, a time interval that includes the known Cretaceous Paleogene boundary, the KPG boundary, dated in 66 million years. The KPG boundary divides the Mesozoic and Cenozoic eras, and it coincides with one of the 5 large extinctions of the planet. This study analyzed the climate changes that occurred just before and after the massive extinction marked by the KPG boundary, as well as its potential relation to this large biological crisis. For the first time, researchers examined whether this climate change coincides on the time scale with its potential causes. The Deccan massive volcanism in India, the Deccan Traps, one of the most violent volcanic episodes in the geological history of the planet, and the orbital variations of the Earth. So Earth even changed its orbit. What happened? Can you imagine? The particularity of the Zumia outcrops lies in that 2 types of sediments accumulated there, some richer in clay and others richer in carbonate, that we can now identify as strata or marl and limestone that alternate with each other to form rhythms, notes the researcher Cesc Battenberg from the Department of Earth and Ocean Dynamics of UB. This strong rhythmicity in sedimentation is related to cyclical variations in the orientation and inclination of the Earth axis, in the rotation movement, as well as in the translational movement around the sun. I mean, can you imagine what Earth was going through? It was probably wobbling on its axis closer and farther from the sun. That would have been something. It's amazing any life was left at all. These astronomic configurations, the known Milankovitch cycles, which repeat every 405,000, 100,000, 41,000, and 21,000 years. So every 21,000, 41,000, 100,000, 405,000. I wonder when the last time this happened to Earth. 21,000 years, regulate the amount of solar radiation they receive, modulate the global temperatures of our planet, and condition the type of sediment that reaches the oceans. And thanks to these periodicities identified in the Zumaya sediments, we have been able to determine the most precise dating of the climactic episodes that took place around the time when the last dinosaurs lived, says PhD student Vincent Gilabert from the Department of Earth Science at UZ, who is to present the thesis defense by the end of the year. The planktonic foraminifera revealed the climate of the past. carbon-13 isotopes analysis on the rocks in combination with the study of planktonic foraminifera, that's microfossils, used as high-precision biostratigraphic indicators, has made it possible to reconstruct the paleoclimate and chronology of that time in the Zumeia sediments. More than 90% of the Cretaceous planktonite foraminifera species from Zumeia became extinct 66 million years ago, coinciding with a big disruption in the carbon cycle and an accumulation of impact glass spherules originating from the asteroid that hit Chicxulub in the Yucatan Peninsula of Mexico that put an end to the dinosaurs 66 million years ago. In addition to the conclusions of the study revealed the existence of 3 intense climatic warning events known as hyperthermal events that are not related to the Chicxulub impact. The first, known as LMWE, and prior to the KPG boundary, has been dated to between 66.25 and 66.10 million years. The other 2 events after the mass extinction are called Dan C2, that's between 65.8 and 65.7 million years ago, and the LC29 between 65.45 and 65.41 million years ago. In the last decade, there has been intense debate over whether the hyperthermal events mentioned above were caused by an increased Deccan volcanic activity, which emitted large amounts of gases into the atmosphere. Our results indicate that all these events are in sync with extreme orbital configurations of the Earth known as eccentricity maxima. Only the LMWE, which produced an estimated global warming of 2 to 5 degrees centigrade, appears to be temporarily related to the Deccan Tramps eruptive episode, suggesting that it was caused by a combination of the effects of volcanism and the latest Cretaceous eccentricity maximum, the experts add. In other words, the Earth tilts every so often. Can you imagine? Now, Earth's orbital variations around the sun, we don't know too much about this, do we? We should learn more about this. The global climate changes that occurred in the late Cretaceous and early Paleogene between 250,000 years before and 200,000 years after the KPG boundary were due to the eccentricity maxima of the Earth's orbit around the sun. I'm just sitting here flabbergasted by this. Our Earth moves and tilts and wobbles around the sun. However, the orbital eccentricity that influenced climate changes before and after the KGB boundary is not related to the late Cretaceous mass extinction of species. The climate changes caused by the eccentricity maxima and augmented by the Deccan volcanism occurred gradually at a scale of hundreds of thousands of years, they said. These data would confirm that the extinction was caused by something completely external to the Earth system. The impact of an asteroid that occurred 100,000 years after this late Cretaceous climate change, the LMWE, the research team says. Furthermore, the last 100,000 years before the KPG boundary are characterized by high environmental stability with no obvious perturbations, and the large mass extinction of species occurred instantaneously on the geological timescale, they concluded. And the reference article is by University of Barcelona, Gilbert Battenberg, Aurelius R's contribution of the orbital forcing and Deccan volcanism to global climate and biotic changes across the Cretaceous Paleogene boundary at Zumeia, Spain. This is from Geology, August 2021, on Bended Reality. Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.